We think we have a pretty good handle on numbers, right? But what if I told you that one of our most basic ideas, the very concept of a prime number, might be built on a bit of a misunderstanding? We're about to dive into this really radical idea called the single prime hypothesis. And trust me, it challenges pretty much everything we thought we knew about the building blocks of math. So, let me ask you something really simple, something you probably learned in grade school. Is the number 7 prime? I mean, it seems obvious, doesn't it? It can only be divided by 1 in itself. But what if that's not the whole story?
Because, and this is the crazy part, according to this new way of thinking, the answer is, well, it depends. It literally depends on the lens you're using to look at the number. And that right there changes everything.
All right, so here's our game plan. First, we're going to explore this little crack in reality. Then we'll take a trip to a world that has no primes at all. We'll find out about the lens that actually creates them and meet the single source they all come from. We'll see how old math problems just dissolve. And we'll wrap up with this really profound idea that reality itself is type relative.
So let's start with that crack in reality. The big question we're asking is, what if being prime isn't some fundamental built-in property of a number like 7? What if it's something that we're projecting onto it?
Okay, so this is from the formal spec, and it sounds super academic, I know, but let's translate. Irreducibility is just a fancy way of saying prime, something that can't be broken down. And a type declaration? That's basically just the set of rules or the system you're using to look at a number. So what this is really saying is that primeness isn't in the number. It's a property that just kind of appears based on the mathematical system we choose to look at it through. To really get this, we've got to strip things way, way back. We need to imagine a much simpler mathematical universe, a universe that existed before we even had multiplication.
Welcome to what's called the base 1 manifold, or just M1. Think of this as the absolute ground floor of math, the most basic world you can imagine. There's no multiplying, no dividing. The only thing you can do here is successor, which just means add 1 or take the next step. It's the world of pure counting. You start at 0, take a step to get 1, another step for 2, and on and on. And this slide right here, this is where it all clicks. On the left, in our world, you see the number 12, and you probably immediately see its factors, 2 times 2 times 3. But on the right, in the M1 manifold, that structure is totally invisible. Without multiplication, 12 is just 12 steps away from 0. The very idea of factors is an alien concept there.
And that leads us to our first huge reveal. In this fundamental reality, this M1 world, there are no prime numbers. The whole concept of prime or composite is completely meaningless because the one tool you need to define them, multiplication, it just doesn't exist there.
Okay, so if primes don't exist in this base reality, then where in the world do they come from? Well, that brings us to the mechanism that builds all this structure on top of that simple counting world. Let's call it the lens of creation.
And the hero of our story is this thing called a type oracle. The best way to think about it is like a pair of special glasses. It lets you take a plain, bare number from that simple M1 world, but when you look at it through a new lens or a new type, all of this hidden structure suddenly becomes visible.
So, here's how it works. It's actually a pretty simple process. You start with a bare number, say 12, which is just 12 steps. Then you pick a lens. Let's go with the multiplication lens. When you look through it, the resolver shows you the hidden structure, and boom, the factors 2, 2, and 3 just pop into view. The number itself never changed, but the way you perceive it has completely transformed. And all of this has been building to the big idea, the absolute heart of this whole thing, the single prime hypothesis itself. It unifies every prime number into one single, elegant concept. So, back in that super basic world of M1, what's the one thing that's truly fundamental, the one thing you can't break down any further? It's the number 1. That very first step you take from 0. The hypothesis gives it a special name, the single irreducible, or pi1. In a world with no division, that first step is the only true indivisible building block. And here it is, the core claim. The single prime hypothesis says that every single prime number we know and love, 3, 5, 7, 11, all of them, they aren't actually distinct things. Every one of them is just a different view, a different manifestation of that one single object, pi1, seen through the lens of a mathematical type that includes multiplication. Now, I know this might sound a little abstract, but what's the point?
Well, the practical payoff here is huge. This new perspective doesn't just give us a cool way to think. It makes some old, notoriously difficult problems simply disappear.
So a framework called the Universal Object Reference, or UOR, was built to make this hypothesis rigorous. It took on 3 really long-standing open problems, and it solved them. Not by finding some brilliant, complicated answer, but by showing that the questions themselves were based on a flawed assumption from the start.
For decades, mathematicians were scratching their heads over problems like these, things like the nature of some mysterious operator called delta 2, or how to deal with number systems built on non-primes. They were looking for these missing pieces inside the old system. But this new model shows that these aren't things you have to find. They're just byproducts of that type oracle we talked about. They're just features of the lens you're using. The problems didn't need a solution. They just vanished once the perspective shifted.
And that leads us to the biggest takeaway of all, a really profound idea, that mathematical reality, and maybe reality in general, is relative to the system we use to look at it. So let's circle all the way back to the beginning. That first question I asked you, is 7 prime? We can now see that just saying 7 is prime is at best an incomplete sentence. It's missing the most crucial piece of context. A much more accurate, a more complete statement would be something like this. 7 is prime when you look at it through a lens that includes multiplication. But in that fundamental M1 world, the question doesn't even make sense. The property of primeness isn't in the number 7. It's in the system we use to view it.
At the end of the day, it all boils down to this one powerful idea. Properties are not inherent to an object. They emerge from the interaction between that object and the system we're using to observe it. Whether a number is prime, whether a problem is hard, it all depends on the lens.
And that leaves us with a fascinating final thought to chew on. If something as fundamental and rock solid as a prime number is actually relative to our point of view, it really makes you wonder, doesn't it? What other absolute truths that we take for granted are really just a matter of the lens we happen to be using?